Hi guys, welcome to a new lesson from CGPs by JangaFX about GeoGen. This one is the complete free bootstrap course about GeoGen from JangaFX. So today we like to continue working on our environment. In the last lesson, we created the initial terrain. That's the project. Today we prepared something for you, something more complex, so you see that we have a lot of nodes. So actually that's the setup we created last time, this one. And here you see the stuff we created to work on something more complex. So I like to show you how it works to understand why we are doing something in a different way. So let's play with the verbs. Let's see how the verbs is changed. So you see that we have a similar way, but we have another blend verb there. And if we go to see the actual verb, that's the shape. If we see the new one, that's the shape. So created something about the distortion. Let's go to see the height map in the base. The old one is this one. You see that it is similar to a standard canyon. In the new one, we created this distortion, and it is really nice. How it works? So we have essentially a blend verb that is working as the previous one. So let's go to see the first one. This is a mask, and this is another mask. So let's go to play directly, for example, with the first verb. So let's go to see this one. Okay, if we go to see the first verb, we can connect this one. You see that we have essentially a canyon, so it's really similar to the previous one. So let's see how it works. Essentially we have a blend verb that is going to play with the base. If we go to disconnect the base, essentially you see the base. It's really simple. How we created this one? We have a position. We created some position variation. You see that there we have no position and no rotation. So this one is not standard. You see that we have 58 and -24 to move the canyon. We have a rotation, so we are rotating the canyon. And then we have also the pivot is changed. We have the scale that is different than before. You see that it's changed. And we have also the relative height that is changed. We have 25%. And the warp amplitude is obviously related to the warp that is used there to make a distortion. And we have also a little bit of offset. And then again, we have the amplitude you see for basic distortion, the scaling for the distortion, the octave. It is not so complex. You see it's really low because we have 1.389 and the roughness is 60%. We made some changes there because you see this one was different. You see that it's different, and we decided to go for something that is smoother than before. So in this way we are creating this shape. You see that is the same we created there, okay? But it is obviously distorted by the basic noise we have there. You can copy the same value we are using, so it is maybe a nice way to create something really similar to ours, but you can play also with more parameters there to make something different. So the first idea was to create this kind of warp. So let's go to have this warp there. And you see that with this warp, we are creating this area there. And that's because we have the mask. Okay, this warp is essentially creating all this distortion. The warps is this one. You see that it's really distorted. So you can copy essentially our parameters. Essentially, we have the scaling, and we have a little bit of value there for the variation for the scaling, the rotation, the output, and something about also the noise. You see that we are using the standard purlin, nothing so special for the moment. Then the scaling is essentially this area. And to obtain something like that, you see that we changed the position to move it over the ground. We scale it, and then that's all essentially, because that's nothing so complex we done. Okay, so in this way we are going to control this warp. So the warp is working just in this area, and then when we go to see the height map, we are distorting just this area. Okay, by the way, we had another warp, this one. You see that it's a general distortion. If we go to see this one, you see that it's essentially a generic distortion as we had before. And this distortion is, you see, the standard scaling, we have a little bit of output, we have essentially something really similar to the previous warp noise. What we done is to mix the stuff. So we mixed the first one with the second one. So the generic warp is the background. The area we distorted with a mask in this area is the foreground. So when we go to mix both, we are using the add. So the second one with a mask will be an addition to the basic distortion. Okay, and in this way we are creating this really nice detail over there. By the way, we created something more. We decided to use a noise mask to create some more generic distortion around. So the idea was, let's remove the modulation. Okay, this one, another generic distortion. By the way, you see it's really detailed, a lot of distortion. And we updated this one, changing to Voronoi. And then you see we made some changes to the roughness and stuff like that. Nothing so special. So in this way, we created this kind of distortion, but we decided to apply the distortion just on some random areas. And the random areas is decided by the mask noise. The mask noise is essentially a noise, so you can change the scaling, you have the octave, it is a purling, so we can change something, but we use it to the full value. By the way, there are a lot of details there, so if you like, you can also go to remove the roughness. It's not important to have the roughness, and maybe it's also better to have a lower roughness. In this way, if we pick this one, then we go to use the modulation, and this one is obviously working more just in some areas. And then again, we are using the previous one as the foreground, as the background, sorry, and then we are using this new warp as the foreground. And we are using the subtraction this time, and we are blending together to 68. If we like to see what is going to happen, is this one, you see it's adding a lot of details around, it's this one. By the way, if we go there and we say let's use 100%, you see that it's really visible. Okay, let's go to back, and if we go to add, you see that it's really distorting. We decided to go for subtract, sorry, to have something different, so we locked this way how it is working. And then, so the warps is changed in this way, but then we done something more complex. In the previous configuration, we had the base, and then we blended 2 height maps, and then we used another mask in the slope to create another different height maps. If you go to see the previous one, you see that we had this one, and then using another terrain, this one, the mountain, we decided to obtain something like that using the mask. Okay, this was the mask. And then we created another really small mountain layer to create something about the mask, to decide to pick just this area over the slope. And then in this way we obtained something like that. So this one was the previous one, and then over the slope we created the mountains. This time we've done something really different. So that's the height map. Okay, then we have another height map. The second one is essentially this one. Okay, we have this kind of mountain with crest details all over, And to do something like that, we changed the position. We used the same rotation as the previous one, and then we use a different scaling. So you see, in this way we are scaling the mountain, the same for the altitude and the same for the warp, but this one is used obviously just when we have the warp. And other things, you see we have the variation there, and also the scaling about the variation. Also the octave is the same and the roughness is the same as the previous one, but we used a different shape. So last time we used the canyon version. This time we used the mountain ridge to create mountains, and you see that we went to have something with more crest. And then we changed the seed just to have a different mountain configuration, because you see, if we change this one, we have a different mountain configuration in a random ways, and we have less details. Okay, you see. And another thing, we used the same graph to remap the shape we used in this one. In this way, the nice thing is that we decided to use the background. This one is the background, the canyon we created. Then we have this one, but we like to add this one just in some areas. And we created the mask using the same heightmap, because you see we are using the slope. It's something strange because we are not using the background, but we are using the foreground to create a mask. By the way, the mask is this one. So you see we are selecting areas on the slope of the foreground. And then when we go there, you can see how this is changing. It is adding this one where the second one, the foreground, have slopes. And we use again the subtraction, and then the other stuff are really basic values. We have just the blend intensity that is something around 50%, but you see that we can decide to have less or more depending on what you are trying to achieve. And again, it is a subtraction, so it's something different than the stuff we done before. And maybe, as I said, it is something strange, okay? By the way, let's go to maybe use this area there, and then we'll see what we've done. Okay, so that's the heightmap we created. Again, we decided to add another layers, and this time we played with the noise. The noise is not the base, it's essentially a noise, okay? So you see, it's something we see in other 3D tools. It's a simple noise. We have the possibility to rotate it, we have the scaling for the altitude, we have the relative height. It works in the same way as the others. And we use the purling, so a really basic setup. You see, we can have more roughness, less roughness. It's a simple noise. And in this way, we decided to change the heightmap using a lot of details coming from the noise. We decided to use a mask. So the mask is essentially a mask shape. So we decided to put some stuff using the noise just in this area. And if you see, it's essentially this area, okay? You see that it's in this area. We decided to do something there, just there. And that's interesting because we like to show you how we can play with mask inside mask. So we are creating a nesting mask, because you see we have the mask shape that is modulating the mask height. So we said, let's use a mask height over this heightmap. So we go to choose the altitude in this area. But we decided to use also this mask. So if we go there in the masking, you see that we are using the blending type to min. In this way, we are using both together, this one and the mask we created with the shape. The mask height is set in this way. You see, we are picking 210 until 250 around meters. So just this area, the red one. And in this way, we are adding the noise just in this area, okay? So this one is a nested mask because we are using a mask to control another mask, okay? Then that's the heightmap we created before. Then we are adding the noise just there and over the top. And as you can see, we have details over there and in this area. Let's go back to see this one and let's see how it changes. Okay, that's really nice. We can pick all this area and say create a comment, and here we say 8 map generation, because this one is the 8 map. The 8 map is finalized, so we have the warps that is controlling the base, and then we have some 8 maps that is masked together to create a new 8 map. Okay, now we have some new feature we are going to use, and we are talking about the filters. Okay, the filters can be created there. Filters, you see, we have the possibility to blend terrain, and we used it together last time to blend terrains. But we have also here, sorry, we can blend terrains, and we didn't use still the blend terrains. We blended just the 8 map, sorry. And then we have the filter water, filter crease, filter crumbling, filter snow, filter sediment, fluvial erosion, and thermal erosion, and shower. We have a lot of stuff that can be used to create some really nice details over the terrain. So this time we use the thermal erosion, the fluvial erosion, and the filter crumbling. We are going to use the 8 map as input for the thermal erosion. The thermal erosion is simulating the thermal condition that creates erosion over the terrain. We can see how this is working in this way. Actually, we are not using mask and we are not outputting the sediments, and that's how it is changing. The filters needs calculation, so we are still in a low resolution, so it's really fast. But when you go with a really high resolution, it can be really slow. Remember that we are using an alpha version, so it's not so optimized, still not so finally optimized. By the way, let's go to see what happens in our environment. So that's the initial. You see that we have a lot of details over the slopes, and that's what happens when we have the erosion. You see that we have erosion over the slope, and then we have the sediments all over. Let's see how it works. We have the largest detail level. This is the level of details where the simulation is running, and I decided to go for 256 meters. We can go, for example, lower, let's say 4 meters. You see that we are losing a little bit of details. If we go up, we are adding details. Obviously, we are going over, we have nothing else. If we go lower, you see that we have a different kind of simulation. Let's go, for example, at an higher resolution. You see that it's working on a calculation. Okay, let's see what happens if we go to rise up. Okay, you see that depending on the area it is working on, you can obtain a different result. So it depends up to you to what you are trying to achieve. You see that's going lower, maybe we have nicer details there because it is working on a really small details. Then we change just the number after iteration. If we go really low, for example 1, you see that it's doing nothing. Then we say 10, you see that it's starting to do something, but the details is really low. Obviously more iteration means more calculation. Let's say 128. You see that it takes a little bit of time, but it is really not bad. And obviously you can go over and over, so I can say, for example, 500, and it is working more. But you have to decide, depending on the level of details and what you are trying to achieve, which is your level, okay? Because you can obtain something really nice also with a lower iteration count. Then the slope limit erosion. We are saying at which angle the erosion is working. Let's say we go really, really low, 10 degrees. Okay, you see that it's starting to work also on a lower slope. So when we have a lower slope, if we go really high, let's say 100. Okay, you see it is not able to make calculation because essentially we have no slope under the 100. So for example, we go lower to 70 and it is able to make the calculation. Okay, so you have the complete control about the degree where you like to have the erosion, and that's the limit. Okay, then max depth of the rain that is eroded during the simulation. Actually it is 30 meters. Let's say we go for 1 meters. You see that again it is doing just some erosion, really lower value, let's say maybe 5 meters. Okay, you see that we have higher erosion. Obviously if we have more meters of erosion, it can remove a lot of terrain and the road. Now it is higher than the level we used before, and you see that we have a lot of erosion. So it depends on the stuff you like to achieve. Let's go back maybe to 30 meters. That was the layer, the level we were using before. Then again, that's the maximum angle of stability of the sediments. So in this way, you see that we are controlling when the sediments are stable, so they will not continue to fall down. Okay, so again, if we set a too much high value, obviously the sediments will not be able to be calculated. Let's see, if we go lower, we can have something more interesting. Okay, here again we have another control to decide how the sediments is let's say included. So it means how much sediments is put together. Let's go for something higher, maybe 80%. Okay, I like to have more sediments all together, you see. And then you can also output a mask. By the way, we are not using this one. So in this way, that's really nice because we are working on all the slopes to create the erosion, and you see that the terrain is really nicer than before. Working on the 4 key was not so slow. By the way, let's go back to 2 key because the next one can be slower. Let's save again the project. Okay, then we decided to create a mask, and the mask is based on the altitude. So you see we are working just on this area, the lower area of the terrain, because we were thinking to have maybe the water over there. So the idea was to create the fluvial erosion, so erosion made by water, like in this example by a river. Okay, so we are using this one. You see that we have the source mask over the rain is coming from. So the rain is coming from there. It is maybe something not so nice because maybe what we can do is to have, let's say, the erosion mask, it's this one, and then we create another mask 8, let's say, for the source mask, saying that the rain is coming from up. So if we go to see this one, we have to connect the 8 map. We go to change. No, I decided to create something different because I like to. Okay, let's go to remap completely. So let's go to move this one up and this one down. And let's say maybe. Okay, let's say that the rain is coming from this area and then it's going down. So this one is the 8 map. And this one you see that is taking a little bit of time to be calculated. So let's go back there. And you see that in this way we are simulating the fluvial erosion. We can try to go with an higher resolution. You see that it's taking a little bit of time. The fluvial erosion and the crumbling can be really slow to be calculated, by the way. Let's wait. You see that it is taking more time. Okay, let's go back to Series 1, and then you see that there we are eroding by the water the environment. So we have this mask to control where the rain is coming from, and then we have where we like to have the erosion. About the fluvial erosion, we are using a really simple setup, nothing so special. So let's go back there. Okay, there are a lot of parameters about the the water. So actually we use the default value. We are going to talk about each parameters in details in the coming lesson. So for the moment, let's use this one as the basic layer. And then you see again we have the iteration. So again, less iteration means less details and less quality, but obviously it means also to have lower amount of time to be calculated. And again, also there we have the value for the largest details, so we can play as we prefer with this one. So let's go, for example, really low, or let's go for 1 meters, and then let's see what happens if we go to 64 meters. Okay, so it works in the same way as we done for the thermal erosion. So nothing more for the fluvial erosion, because we have to work more on this terrain later, and I like to talk more about the parameters there for the thermal erosion and the fluvial erosion. So today we are going just to introduce the filters. Then something more, we are going to create the crumbling. The crumbling is a filter that is going to simulate rocks climbing down from the mountains. Okay, that's really nice because it can create sediments of rocks all around. So a mask, again, we decided to remove the sediments just there, sorry, the rocks, and I go to show you how it works. Let's go to see the output. Okay, you see that it's going to add rocks down in the terrain, but it's breaking the terrain all around. Okay, you see a lot of holes around. If we say please remove just over this slope area, you can say that when we go to connect this mask to the emission mask, we are saying that we like to emit the rocks just in this area. And then we have the sediments down. How it works, we can see some parameters there. By the way, we are going to talk about the parameters more in depth next time. So essentially I changed the debris amount, for example, because we can say 50 debris, it is calculating. You see that we have maybe some rocks, not so much. If I start to say 500, we'll see that it's breaking more. Okay, so I decided to go for a really high value to create a lot of rocks down. Then other things, that's the angle for the spawning, but we were going to see. I changed the size debris. So we are talking about 0.5 meters minimum to 10 meters maximum. Obviously, if we say, let's say 2 meters, we'll have smaller rocks and smaller holes. You can see the rocks there. Obviously, the level of details is not so much. We can rise up to see what's going on. Let's wait for the fluvial erosion. You see that it's starting to take time to make the calculation. Okay, and this needs to be ready. Remember that it's using completely the GPU to make the calculation, so depending on the GPU you have, it will be faster or slower. So you see that now we have more rocks, but it's smaller. If we go to a really high value, we'll have something really big. Okay, you see, it is really crazy. By the way, let's go back to something more interesting. The next thing is that obviously it needs not to redo calculation about the other stuff that was done before. And something more, I just changed the types of rocks. We have simple, complex, flat, on sphere. I decided to go to complex. And here you have some parameters about the variation between the rocks, the shape. We have 0 to max 20%, but we can decide also to go higher to have more and more variation. Let's wait for the calculation. Okay, we have more variation on the rocks. And other things, the dig intensity, that's how the holes is deep, done by the rocks. So if we say, for example, 0, you will see that the rocks will create less digging over the ground. So you see that it's up. If we say that the dig is 100%, obviously it will be able to dig more inside the terrain. Okay? And then we have, let's go back to our value that it was, if I remember, 80%. We have the offset of the dig, so we can create also an offset. And then we have the fill intensity. It will be able to say which is the final 8 position for the rock. Let's say, for example, 0%. And you will see that the 8 of the rocks will be changed because it is not more visible. Let's say maybe 25%. We should start to see something. You see that the rocks are rising up. Okay, you see that more and more it is coming out, and we can see more the rocks. And again, we have also the offset to add a bias to the position. By the way, in this case, I like to see the rocks because the rocks will be inside the water. We have motion parameters, we have blending. By the way, again, I didn't touch the other values, so we'll see how it works step by step in the coming lesson. So we have this train. What's going on later? I created also a camera. The camera actually is not completely working. There are some small artifacts and bugs and still some features that are not working. By the way, the camera position works, so you can use it. You have just, for the moment, you have just to create the camera, and then you will be able to pick the camera there in the view. By the way, let's go to, we have the mask occlusion there, the colorides. So we can essentially remove the old one, and then we can go up this one. And let's say that there we have erosion and rock crumbling. Okay. Let's move the camera there. We have the colorides. We have to use this one because that's the output. So connect to the base. Sorry. Was connecting in the wrong way. So the output to the heightmap, and then the output from the colorides to the color. We can output there, and you see that we have our terrain. So I've done something inside the colorides because I prepared some, you see, some gradient. This one was the old one we were using. It was really simple. Then I picked something over some photos, so sometimes you see they are disappearing. Maybe this just a bug. To pick the gradient, remember that you have to open a photo, for example an image, then you pick the color picker and you have to drag with the left mouse button over the image to pick all the colors you like to pick, and then you can remove the left mouse button and the gradient will be created. The gradient obviously can be changed and you can play with it as you like. You see that I picked some stuff from other photos, so in this case maybe some can work nicely, others cannot work nicely, so it depends on the stuff you are doing. And you have also always the possibility to remap the colors, so you can play with the stuff as you like. Let's see, let me change this one. Okay. Nothing else about the colorites. We can do something over the render. The light is there. We have the light as this value, 113 for the azimuth, 43 degree for the elevation. Other stuff are not changed, but I like it to add the planet atmosphere. So you see we have the atmosphere in our environment, and then we can add a little bit of fog. In this case the fog can be, first of all, maybe a lower intensity, let's say maybe 2.5. The scale maybe a little bit lower, let's say 150. So we have a little bit more details, let's say to constrain to the terrain. So we have the clouds just over the terrain. And then maybe we can just make it a little bit less covered, let's say 45%. So we have a little bit of clouds around. The other things I like to add is the water. Okay, you see that now it's really low. We can say that the water is higher, maybe not so much higher, because I like to see some small rocks. Okay, maybe also just a little bit more. Let's let you remove just for a moment the fog and the atmosphere to speed up the stuff. Okay, you see that now it's faster to make calculation. Maybe again just a little bit lower, let's say 118. Let's go lower, 115, because I like, oh sorry, because I like to see a little bit of rocks there. The wave scale is changed because I'm using the 10 meters. You see that we can make it bigger or lower. So let's say that we can also have an higher amplitude if you like to see more visible waves. But again, I like to have something less visible, let's say 0.5. And then if you like, you can have an higher opacity or lower opacity, depends on the stuff you like to simulate there. Let's go to a lower level. Okay. Let's go back to, if you like, you can also use the depth of field. Obviously this one is not nice because it is something really small. We can change the focus distance, let's say maybe 50 meters, so we are something around there. If you have a bigger size for the sensor, you will have a lot of depth If we go really low, let's say 0.1, we will have less. Okay, let's remove it because it is not needed actually. Let's go back to have the atmosphere, and let's go back to have the fog. So that's the actual status. I really like how it's going, really nice. And we are going to talk about more in depth about the parameters for the thermal erosion, the fluvial erosion, and the crumbling in the lesson number 3. And then we'll play a little bit with the color rights, and then it is time to export stuff. So we are going to create something really nice out of GeoGen. So our first lane will be over and will be ready to be used in production. And then we'll go back to talk about other nodes and other features to see how we can manipulate environment and how we can create different kind of environment. So that's all for this lesson. It was enough because it is 40 minutes for the moment, so I don't want to make something bigger than before. So thanks for watching, and we'll talk more about the GeoGen nodes in lesson number 3. Bye.